Mathematicians,
That's me.
that is you. I'm so glad you guys are with me. Now today we are going to be talking about more story problems. And when we're working on these story problems, you're going to start making all those connections that we've been doing all year of different ways to solve the problem. So again, like a story problem, we're going to look at the situation, think about what is the story problem asking us to do, and then based on that, we can then decide how are we going to solve it. So in this lesson 5, I'm going to talk about problem number 2. So Tommy's going to come on over and I'm going to have him show it. Number 2 is the top of a bookcase is 24 inches from the ceiling. The ceiling is 96 inches tall. How tall is the bookcase? So friends, there's important things in that story problem. We know that the top of the bookcase is 24 inches from the ceiling. So in number 2, I made kind of a picture of a room. There's my bookcase. That's kind of my own idea of a bookcase. And then here's the ceiling. And it's saying that the top of the bookcase is 24 inches from the ceiling. So that means from here to where the ceiling, it's 24 inches. I needed to have this situation so I could understand what was happening. And then I said the ceiling, though, is 96 inches tall. So from the ceiling to the floor is 96 inches tall. I'm trying to figure out the spot of how tall is the bookcase. This is what I'm trying to figure out. I know from the top of the bookcase to the ceiling is 24. The total of it all is 96. I could be thinking, well, this 24, right, plus this unknown, that's the bookcase. That's what I'm trying to figure out. The bookcase, I'm figuring out its height. That's my question. But when I have these two together, they give me the whole total of 96. So friends, in this case, I know the total. It's 96. I know one of the add-ins is 24. I am again looking for that unknown. I'm looking for how tall the bookcase is. I can solve this in different ways. I hope some of you know that you could use the add-on to get to 96. I could also subtract 24 from 96 to see what's left. I'll do that one. 6 take away 4 is a 2. 9 tenths take away 2 tenths is a 7 tenths. 72 inches. That does make sense. If this then is 72 inches, that would mean 24 plus that 72. It should get me back to 96 as the total. Friends, it does. So that does check. I did the opposite operation to make sure of it. So I was looking for that. Let's look at number 7. In your sheet, number 7 says, Nick and Ben are running a relay race. Nick runs 48 meters. Ben runs 37 meters. Oh, how many fewer meters does Ben run? I hope you guys are thinking comparison bar. You're right. And even if you're sitting there saying, Miss Seitz, I can figure this out already. Great. But the situation is asking us to compare. And again, when you're looking at a word problem, you want to think, what is the problem asking me? What is the situation? And then I can solve it the way that makes sense to me. So Nick and Ben are running a relay race. Nick runs 48 meters and Ben runs 37. They want to know how many fewer meters does Ben run. So friends, we know that this circle in our comparison bar, right, it stands for the fewer. And if it stands for the fewer, it also stands for the more. But we're really looking for the fewer in this case. We know that Ben ran 37 and Nick ran 48. Nick has the bigger bar. He has 4 10s, 8 1s. I'm going to put an N there for Nick because I'm comparing it against my friend Ben, who has 3 10s, 7 1s. This is a greater number. A greater number always will own that greater bar. And now I can compare them. Nick is greater. How much more? But we want to know fewer. Same number, just going to use the word fewer. Ben is how much fewer? I could subtract to find that difference, to find that fewer. I could also have 37 and I could add on to see how many fewer. I'm going to add on. I'm going to say 37 plus 3 got me to 40. And then 40 plus 8 more got me to 48. I added on, I know you're yelling me 11. 11. So 11 is my answer. That means Ben is 11 fewer. Nick is 11 more. I hope that's clicking for you. These can be challenging, but we've been swimming in this deep end all year. So my mathematicians, that is you, this should start making you think, what is the method I'm going to use? Let's look at another set of story problems. This problem is number 8. So if I go to number 8, we have Mrs. Rossi is putting a fence around her garden. The garden has 4 sides and 4 right angles. Each side of the garden is 23 feet long. How long will the fence be? I hope we're remembering what we know about shapes. It's telling us 4 sides, 4 right angles, and then it's only giving us 1 measurement for the side. Yeah, it's a square, which is a type of rectangle, but it's a special rectangle. The square is super cool because every side is the same, unlike a rectangle. We know that. So right now we're looking for the perimeter, the distance around. And we know that her garden has 4 sides, and they said that all 4 sides are equal. So I'm going to try my best to make an equal square. And then it says that each side is 23 feet long. That means this is 23 feet, this is 23 feet, this is 23 feet, this is 23 feet. And right now, you're looking for the distance around. You're looking for the perimeter. Now, some friends, I know you love the challenge. Some friends are going to add up all the ones. I'm going to do that. 3 plus 3 plus 3 plus 3. That's 4 3s. I could think of multiplication, 4 groups of 3. 3 and 3 is 6. This 3 and 3 is 6. 6 and 6 is 12. I added up my 1s. I'm going to add up my 10s now. 20, 20, 20, 20. I can count by 2s. 2, 4, 6, 8. But they're 10s. 20, 40, 60, 80. I could then add it to 9 10s. I could do it that way. Could have I added 23, 23? I could have done that, right? 46, and then the other 23, 23. I could have done that. Another 46, and then I could add those 2 46s. Let's just do it and show off. Here we go. I know, you're yelling 92. That makes a 12. Leave my 2 1s behind. Carry that 10. 40, 40, 10. You're saying 90, I hear ya. So friends, again, how you get that distance around, decide what is it that you're choosing to do. Look at this one, I just added up my ones and then added up my tens. I felt pretty comfortable. Maybe you too. It's a method. It's how you're choosing to solve. Know the situation so you can solve it. Friends, our last one we're hanging out together with is number 11. And number 11 is about a flagpole. Number 11 from lesson 5. A flagpole is 62 feet tall. The flag covers 11 feet of that pole. How long is the part of the pole that is not covered by the flag? So here we go again, friends. What is the situation? We have a flagpole. Oh yeah, friends, I'm making a picture. The visual is very powerful. And of that flagpole, it says the flagpole is 62 feet tall. So from here to here is 62 feet. Friends, they're not saying that they're adding 11 feet. They're saying the pole is 62 feet tall. But the flag, that's why I got a visual, it covers 11 feet. So from here to here is 11 feet. See that? Oh. So now they want to know, right, the part that is not covered. So, wow, that part. They're looking for that part. The part that's not covered. The whole pole is 62. We know the total, friends. Here we go. We know the total. We're not adding 11 feet. We're saying the total is 62 feet. That's the whole pole. The part the flag covers of that 62 is 11 feet. So they're saying, what is the other part of the pole? What's the other unknown add-in? That's the part that's not covered. That's what you're looking for. If I had to do a situation equation, I might say 11 plus what? That's that part. The part that's not covered, right, equals 62. And we're talking about feet. So they just want you to know, what's this part here? You're looking for that other unknown. So friends, today I just wanted to walk through a couple of those problems from lesson 5. Friends, this can be challenging. This could be comfortable. All I'm asking you to do is to jump in that deep end, do a little bit of swimming, revisit the video. I miss you. I'm glad that you're being the best that you can as a mathematician, and that's all I'm going to ask of you. Do your best. And every day I want you to choose that math joy, that I get a chance to practice my math skills. I'm a mathematician. I'm a math monster. Yeah, I am. So are you. Have a great day. See you later.